Hello, everybody. In the next couple of videos, we're going to be taking a step back and just focusing in on quadratic equations and different strategies to solve quadratic equations. So the first strategy we're going to take a look at is solving quadratic equations by using graphing. It's something that we've graphed quadratic functions before. So just quickly, we have discussed how to graph quadratic functions, and this is going to help us solve quadratic equations. So what we're going to do is I'm going to teach you guys how to use the graphing calculators, a little bit of technology to help you graph quadratic equations, and it still takes a bit of thinking to kind of set up the function that we're trying to graph in order to solve our answer. And then what I suggest is you probably don't have a graphing calculator on hand, but there's all kinds of online resources. Desmos is a great one for helping graph. So it's Desmos, right? There's a couple of graphing tools that you can download. One of them is literally just called Graph. I think it's Graph 4 point something or other. I can't remember exactly off the top of my head, but it's just another graphing tool that you can use to help you graph these things. So what do I mean when I say solving quadratic equations? Well, a quadratic function, something that we've dealt with in the past, would be something along the lines of y or f of x equaling ax squared plus bx plus c. That is a function where we have two variables, right? We have a y and an x, and that thing is a function because there's a relationship between those two variables. An expression is ax squared plus bx plus c, where it's just the quadratic without an equal sign. It's not equal to something. There is no answer. That's an expression. A quadratic equation is kind of the halfway between the two. A quadratic equation is still that quadratic expression, but now it has an answer. And we have many strategies that we can use to solve this quadratic equation. And we've talked about some of them in the past, right? To solve these equations, we can use a number of methods like graphing, factoring, completing the square, and the quadratic formula. Factoring is one you should be very familiar with, really comfortable with. The quadratic formula is one we've discussed in the past. Graphing might be a little too new, and even completing the square. I know we've talked about how to complete the square in the course, but we haven't necessarily focused in on how to use that to solve these things. So let's take a look at how we're going to do this. So to solve graphically, what we're going to do to solve the quadratic equation graphically, we graph the corresponding quadratic function. So again, we consider this example for a second. And what we're going to want to do is to take this equation or this expression, this part of my equation, and make a function that's equal to that. So make the function f of x or y. Well, here I'll use y just to make sure you guys are comfortable. So y equals x squared minus 5x plus 6, right? So we're going to graph this thing. Then, once we have the graph of this thing, what we're going to do is we're going to look at our graph and say, okay, now where does this thing equals 0? Because that's what we're trying to solve for. We're trying to solve for when this function is equal to 0. So on our graph, it has y values of 0 here at 2 and here at 3. So that's how we solve these things graphically. Now this one was pretty straightforward. So let's just take a look at a couple of examples here. So let's take a look at this one here. Negative x squared plus 8x minus 16 is equal to 0. Since this is solved so that the function is equal to 0, we can just graph this function as is. So what we're going to do is we're just going to take the graph of y equals negative x squared plus 8x minus 16. We're just going to take that graph, and what we can do is, I know we're not in class, we don't have access to our graphing calculators, but when you get back into class or even next semester when we start doing these things, what we're going to do is we can use these graphing calculators. Now, most classes, they'll either have a class set or you'll have access to one. And what we can do is we can actually use these to graph quadratic equations or any type of equation, really. So what we can do is we press this y equals button. And you'll see here there's a list of different equations. So you can graph multiple equations on the same graph. So we're just going to stick to the one. So what we're going to do is we're actually going to type this out. So negative x squared plus 8x minus 16. And what we can do is if we hit the graph button, it'll actually take that graph and it'll plot it for us right here. So now, if we take a look, what we end up with is we end up with a graph that looks something like this, where it touches just here on the x-axis at x equals 4. So what that means is the answer to this question is x is equal to 4. Nice and easy. Now, let's take a look at one that maybe add a little bit more context to it. So here's a word problem. And what we have to do with these word problems is we kind of have to think about, all right, well, what part of the graph is this asking me to solve for? So the manager of Jasmine's Fine Fashions is investigating the effect that raising or lowering dress prices has on the daily revenue. The function r of x equals 100 plus 15x minus x squared gives the store's revenue in dollars from dress sales, where x is the price change in dollars. What price change will result in no revenue? So what this is saying is that r of x is the revenue and x is the price change. And what the question's asking us to figure out is, well, what price should they change it by in order to get no revenue? Right? So what is that asking us to do? Well, it's asking us to say, when will r of x equal 0? Or in other words, when will you get this answer? 0 is equal to 100 plus 15x minus x squared. So again, we simply need to set this function equal to 0. And what we can do is we can graph it. So let's take a look at our graphing calculator. And again, if you don't have a graphing calculator, there's online resources available, so I suggest checking those out. So what we're going to do is we're going to use our graphing calculator to do this. So we're going to clear that. So we're going to put in our function 100 plus 15x minus x squared. Okay. And then we're going to make sure that we can see it, right? Because what's going to happen is if I hit graph right now, we're starting off with a y-intercept of 100, right? That c value is 100. So our graph probably isn't set up in a good way to see it. So what we can do is we can adjust our graph by hitting this Windows button. And what you'll see is that the x-axis goes to the left 10 units and to the right 10 units, and the y-axis goes down 10 units and up 10 units. So when I look at my graph, that's all I'm seeing. I'm seeing 10 units to the right, 10 units to the left, 10 units up, and 10 units down. But right away, we already know that our y-intercept is 100, so it's not going to fit on my graph. So what we need to do is to change our windows. And here's the windows I suggest. So we're going to go into our windows, and here where it says x min negative 25, well, that's what we'll put. We'll say negative 25. And then the x max suggests 25, so 25. And for the y min, I suggest negative 1. And then for the y max, 250. And more often than not, what you're going to have to do to choose these windows is just play around, right? Throw in some numbers that you think make sense, and then hit the graph button. Let's see if it brings up a graph that's going to help us out. If it doesn't, then let's try a different set of numbers. Okay, so how does this graph help us? Because if you take a look at my image here, well, what is the x-intercept here? What is the x-intercept here? We're going up and down 25 units, and it could be a decimal. So it's hard to say exactly where the x-intercept lies. So again, what these calculators can do is they can help us find that information by using the tool in the calculator. So what we're going to do is we're going to hit the graph button, pulls up our graph. So from here, how do we find the x-intercept? Well, what we're going to do is we're going to hit the second function and this trace button. And what that's going to do by hitting the second function, it's actually going to hit the yellow word there that says calc. And what that does is it allows us to calculate some values. So for example, if we're trying to figure out when this function is 0, that's the value that we're going to calculate. So we're going to hit go to the 0 and hit enter. And we'll get a question here. It says left bound. So what this wants us to do is it wants us to take this little x and move it until it's to the left of our x-intercept. And what's going to happen is you'll notice as I push the button here, the y and the x values are going to change. What we want to do is figure out, okay, well, this y value is positive, and when it passes through the x-intercept, eventually it's going to become negative. So if I hit the button once, 5 point something, oh, I'm down at negative 8. So I should be to the left of my x-intercept. So I'm going to hit equals, and then it's asking for a right bound. So now I'm going to move it to the right until my y value turns positive. And hit equals again, and it's going to ask a third question that says guess. So if I hit equals a third time, it's going to give me an x-intercept of negative 5. Right, so I do left bound, I do right bound, And then what happens, it gives me an x-intercept of -5. And then I do the same thing. So here, if I write that down, we know that -5 is one of our answers. And then if I do the same thing, so second function, calc, go down to the 0, equals, I'm going to do the same thing for my other x-intercept. So again, I'm going to go left bound. So I'm going to make sure I'm to the left of that point. So I'm going to go over, right? And just keep going over until I get to the point where my y values turn negative. Now again, I want to be to the left of this x-intercept. So I want the positive y value. I'm going to hit equals and then get a negative y value and hit equals again. And again, that third question says guess. So I'll hit guess and it gives me an x value of 20. So what that means is that my x values here are -5 and +20. So what that's actually telling us, again, if we go back and we read the question, so that the x value represents the price change, right? The change in the price. So if the original price was $100, so what this is saying is that the store will make 0 revenue if they decrease the price by 5, or in other words, charge $95, or they increase the price by 20, right? Or in other words, charge $120. So that is when they will reach no revenue. Okay, so these graphing problems, and we'll do a couple more together. So what you'll find sometimes is when we're trying to solve questions like this, they won't always be equal to 0. And there's two ways to kind of consider this question. So again, what we're going to want to do is we're going to want to graph it, right? We want to solve this thing graphically. And how we're going to do that is by making it into a function that's going to be y equals something. Now, be careful, right? What should y equal? Should y equal 2x squared plus x? Because if you do that, then what you need to solve for on your graphing calculator or your whatever electronic tool you're using, you have to figure out when will y be -2. And a lot of these tools don't have a feature built into it to find some specific y value. So you have to be careful about that. So what would be better is if before we get to graphing this thing, we're going to take it 2x squared plus x plus 2 and set it equal to 0, because a lot of these electronic devices do have a function built into it to find the 0, right? So what we do is we set it equal to 0, then we take the graph of y equals 2x squared plus x plus 2 and say, okay, now when will this thing be equal to 0? Right? So if we plug that into our calculator, so if we take the 2x squared plus x plus 2, and we graph this thing, and maybe I'll try to zoom in a little bit here. So maybe we'll reset my windows to -10, 10, -10, 10. And again, right, like you have to kind of play around with this to get a window that looks nice, right? But what we're looking for is the x-intercept. And what we notice is that this graph actually never passes through my x-axis. So if that's the case, if this graph isn't passing through my x-axis, then there are no solutions. There is no value that we can plug in here for x and get an answer. And another way of checking that is we've talked about in foundations, we talked about something called the discriminant. And what you'll find is that if you try to use some other method like the quadratic formula, this thing is just going to give you an error. Okay, so this is just one of a couple of different videos I'm going to make about solving quadratic equations. So we'll do one more example together. Maybe you might want to pause this one and then try it on your own. But we'll do this one together, and then we'll just we'll call this video a day, and I'll post another one in a bit. So let's solve another one of these. The curve of a suspension bridge cable attached between the tops of two towers can be modeled by this function here. H of d is equal to 0.0025 times d minus 100 squared minus 10, where h is the vertical distance from the top of a tower to the cable. So h is the height, right? Height's it's like the distance below the tower, so it's the height kind of going down, and d is the horizontal distance from the left end of the bridge. So of the bridge, not necessarily the tower, but of the bridge. And both of these values are given in meters. So what this question wants to know is, what is the horizontal distance between the two towers? So what is the distance from this value right here and this value right here? So this cable is your graph, right? It follows this function right here. And where this cable touches this kind of plane, the top of the towers here, right? That's where we want to find the distance to. Or in other words, we want to find the distance from x-intercept here to the x-intercept there. So if I find my two x-intercepts, then I'm just going to subtract those numbers in order to find the distance between them. So again, in order to do this, I'm going to pull up my graphing calculator, my electronic device, whatever it is I'm using, and I'm going to plug in my functions. So we get 0.0025 bracket. I'm still using x's, right? The calculator doesn't distinguish between any variables. It's just any variable will be this button right here, the x button. X minus 100, close my bracket, and square it, and then minus 10. Okay, so this is what I need to graph. So again, what's probably going to end up happening here is I'm probably going to end up with a graph that isn't the nicest just because the windows aren't where they need to be, right? We know our x and y intercept, right? Because, or not, sorry, not intercept, but the vertex, right? Remember, this thing is in vertex form. So right away, we know that I'm going to have a vertex at 100. So my x is probably going to have to go from 0 all the way to 200 at very least, probably even more than that. So maybe I'll go 250 just to be safe. And then my y, we only care about the part of my bridge that's below my x-axis. And again, the vertex here is -10. So maybe I'll leave that at -10 and just make this 0. Or maybe I'll make it like 5 so we can get a glimpse of what we're doing here. So if I graph this, and there we go. There's the cable here. And we're looking for my x-intercept. So again, second function, calc, go down to that 0, right? And you see that flashing x there? What we're going to do is we're going to take that flashing x and bring it to the left of one of my, bring it to the left of one of my x-intercepts, and then bring it to the right of the same x-intercept, and we get x is 163.25. So 163.25, right? Do the same thing here with my other x-intercept. So second function, calc, right? Go down to the 0, hit equals or enter, right? Again, move that x to the left of my x-intercept. So that little flashing x you can kind of see moving right there, slowly moving as I click. So I move it to the left of my x-intercept. I'm going to hit enter and then move it to the right. I'll hit enter again. And again, it might not look like it, but I can see my y values change from positive to negative here. And then hit enter a third time, and we get x is 36.75. So x is 36.75. So now what that means is these are my two x-intercepts. So now if I subtract these two values, I'm going to get the distance between them. So the distance between them is 120 6.5. And our units were given in meters, so we are also in meters. Okay. So again, what I'm planning on doing is releasing a couple of videos on the different types or different ways of solving quadratic equations. By the time I've made the second or third video, I should have a worksheet out and ready for you guys to do. Okay, so be looking for the second video, and I will see you later.